Hey everyone, I'm Harsh from LocalStack, and today we are going to learn about team collaboration using LocalStack CloudPods. CloudPods is a part of LocalStack's team collaboration feature that basically aims to reduce friction and improve the productivity of cloud development teams. To help us understand more about CloudPods, we have Joe with us, who is one of the engineers working on the CloudPods feature. So, hi Joe, thanks for joining us. Would you like to introduce yourself?
Hi, Harsh. Thanks for having me, and thank you for the introduction. As you said, I'm one of the engineers working on CloudPods, so I'm very happy, very thrilled to be here today and to talk to you and to our users about CloudPods and about our the recent development for CloudPods.
Awesome. Thanks for once again for joining us. So in today's video, we are going to dive deep down into LocalStack Cloud Pods and how it exactly works. And we will also be showcasing a live demonstration of how you can collaborate together using LocalStack Cloud Pods. To follow with this video, all that you need to have is a running LocalStack container with a few AWS resources, just like an S3 bucket or maybe a Lambda function, and you would be ready to start. But before jumping into the technical demonstration, I guess we can talk a bit about what CloudPods really are. So, Joe, would you like to walk us through what CloudPods are and what use cases does it potentially serve for me?
Yes, of course. So, like by default, the state in local stack is ephemeral. That means that once you restart the container, the actual state is gone. So there is no need, no way to actually recover the state. However, like in some cases, for various reasons, users might want to be able to persist the state of local stack. And Cloud Pods basically address this issue. They offer a way for users to take a snapshot of the state of the local stack instance. And you can do like a lot of different things with this instance. You can re-inject it at a later point in the future. You can store it. For that we offer like a storage backend that people can use to store the snapshots. And more importantly, these snapshots can be shared across team members for collaboration. So if I want to collaborate with you, Arsh, and I have my local stack state, I can take a snapshot of it and put it on our Cloud Pods backend, and you can download it and inject it into your running application.
Awesome. That simply makes a lot of sense. So I have a question on this. Like LocalStack has a pretty niche feature called as persistence. And that basically also allows us to persist our AWS resources that we have created using LocalStack. So does CloudPods basically provide the users a way to store this state onto some remote provider, like maybe the LocalStack web application? And this is what makes it different from persistence. Am I right about it?
Yeah, basically yes. So they both like try to solve like a similar problem, but the use case is very different. So with persistence, basically you're making sure that when the container restarts, the service state is the same when it stops. But you don't have this fine granular control over your state. With cloud pods, you have much finer granularity because you can decide when you want to take a snapshot, when you want to restore it. You can also decide, for instance, to take a snapshot only of certain number of services. Maybe you have like a large state, you want to take a snapshot only of your S3 service. You can do this and much more with cloud pods.
That sounds pretty awesome. I also believe that CloudPods might serve a use case for a lot of people who might be collaborating on a day-to-day basis. Like, let us say I'm trying to collaborate with you and I'm just working on an infrastructure and something is pretty much going wrong. So I can just convert that into a CloudPod. I can also configure some of the services that I'm facing troubles with, and I can convert that into a CloudPod. I can share it across with you, and you can possibly help me out with fixing things or maybe even developing on top of it. So I perfectly see the use case behind CloudPods, and I guess it would be delight to see how the technical demonstration actually plays out. So we can maybe jump directly into the code. So Joe, would you like to walk us through the simple AWS project that you have? And we can maybe try to deploy that on local stack. And we can also see like how we can directly convert it into a cloud pod.
Yes, of course. We're gonna basically do what you said. We are going to take like a pet project, let's say, that we took from the official AWS docs. I can briefly show it to you what's it about. This is the page on the AWS documentation. Basically, this is a tutorial on how to use S3 triggers to create thumbnail images. Basically, what it does it configures S3 triggers in a way that once an image is created in a bucket, a lambda function is triggered. This lambda function basically takes the image, put on the bucket, creates a thumbnail out of this image, and put this image into another bucket. You can follow along this tutorial. You can see different steps and the actual coded lambda that does this conversion for the thumbnail for the thumbnail. You can follow it along, but we have like already a prepared script where you can basically create the state as this tutorial describes. And I'm gonna show it to you. We have prepared this small script. It basically does at high level what I described. It creates two buckets, like a source bucket and a destination bucket, creates like an AM role that's needed for the lambda function to run, and then creates like a configuration for the lambda function and creates basically the trigger that tells, okay, when something hits the bucket, please trigger the lambda. This is the high level. We're going to run basically this script against localstack now to create a state, and then we try to basically create a pod out of it. For this to work, first start localstack. So I'm going to start it here. You can see it on my terminal. This is with debug enabled, so it's very verbose. And while this is starting, let's starting the script. Let's execute the script to have our state created into localstack. You should see prompted to the terminal, the different resources created, the buckets, the role. Now we should see the function created. And yeah, basically now the script is over. Let's see if something has been created. So we said there are two buckets. We can see them, two buckets. We should also have like a lambda function here. Here it is. So to trigger the lambda function, we said we should update an image on the bucket. So let's try to do this. I just have always by convenience a Pikachu image in my download folders to be used for tutorial purposes. So let's try to put this image on the bucket. Let's see what happens. On localstack output logs, you can see lambda was triggered, and you can see in the logs that the image was resides and uploaded to the other bucket. So we can actually see, inspect this bucket, and we actually see, oh, the image is there. So it seems to work on localstack. Now let's try to create a pod out of it. To create a pod, we need to run the save commands. So you can learn about pod commands just basically running the help in your terminal. For instance, for the pod save, you get a description that this command saved the current instance of the container in a cloud pod. You see a description of what the command does. But for the sake of this tutorial, we're just going to run the basic command where we just call localstack pod save, and then we specify a pod name. This is going to create basically a pod and register this pod to our storage backend, where you, Harsh, are gonna able to actually pick it up and inject into your localstack instance. So let's just run this command, localstack pod save, and we pass the name of the pod. In this case, it's gonna be called thumbnail lambda. So now basically, localstack internally is collecting all the states and packaging everything in a zip file, providing this zip file to our backend for you later on to basically inject it. We should get like a message soon that the operation was good. It's gonna take a bit because it needs to basically update the zip file on the storage backend.
So I have an interesting question for that. What if someone doesn't want to upload their local stack state upon localstack's remote provider? Like, what if I just want to save it as maybe as a file on my own local machine? Does localstack provide any sort of an option for that?
That's a very good question, actually. So we do provide this possibility. So basically, it's with our CLI, instead of basically saying localstack pod save the name of the pod, you can basically pass path on your local machine, and the same format is going to basically be dumped on your local machine. It's not gonna be pushed on our platform. And basically you can take this output and like give it to your colleagues in the similar way, and they will still be able to inject it. Of course, they lose the convenience on having the platform managing the state of the snapshots for them. But like very good news that this feature of like dumping the state locally is available to all our users, also to the community user. You don't need any license to basically be able to create pods locally.
So that definitely makes sense. I guess we can also use a provider like, let's say, GitHub or maybe even GitLab, so that we can push our cloud pods over there, and maybe some of our colleagues can just directly reference that.
Yeah, totally. We offer this possibility as well. So we are slowly building a nice repository that you can find. LocalStack Cloud Pods is the name of the repository, but it basically we store some pre-baked pod, let's say, and you are able always to inject pods from a public repository. We offer this opportunity. This is also for free, available to all community users.
That sounds pretty great. Thanks a lot for sharing that with us. Since we are a part of the same organization, I definitely want to see if this particular cloud pod is visible on my side. So
Yes,
maybe I
so
can.
the
Yep,
pod has been created, so now you can actually try to load it on your machine. You will be able to see it in your results process if you go to the cloud pod tab.
that is pretty awesome. I definitely see the thumbnail lambda created as a cloud pod over here. Can you explain to me what this particular ID does, or what this browser exactly means in this case?
So this browser is basically a way for the user to visualize what's in the cloud pod itself. So this is like a JSON representation of basically the content of the pod for you to grasp like an understanding of what's in there. So this is like a first implementation. We are building as we speak, like a even better way to visualize and to query the content of a cloud pod. So please stay tuned for new feature to be released soon.
That sounds great. I guess I can give it a shot and maybe try to load the cloud pod on my own local machine. So since you already mentioned that we have a save functionality to save our local AWS infrastructure into a cloud pod, how can we exactly go about loading these cloud pods on my own local machine?
So basically, the counterpart of the save command is called the load command. So basically, the command is the same, localstack pod load, and then you give it the name of the pod we created.
Sure. Maybe I can try starting my local stack instance first, because that's one of the first necessities. And I can maybe try giving local stack pod load. I can use the help functionality to check how I can get started with this. I guess all that I need to do is specify the name of my cloud pod that is already pushed onto the
Yes.
platform. So I can say like local stack pod load and maybe thumbnail lambda, which is the cloud pod that we have already created. So can you also explain to me like what these strategies exactly mean here? I guess I see a merge, override, deep merge. So what is the exact purpose of these in the context of cloud pods?
That's a very good question. So once you load the pods, that pod needs to interact with your local state that you are currently having your local stack instance. And this can be done in a different way. So you can override the state of your local stack container with what's in the pods, or you can do like a merge, but this merge is disjoint, for instance. Let's say you have like a S3 bucket on your local stack instance and you're pulling a pod with a DynamoDB. These two states do not conflict with each other. So the resulting state is going to be like S3 plus DynamoDB. With deep merge, like we offer like a advanced functionality. Let's say you have like a table called music, where we have some music songs in there. And then you have a pod with another DynamoDB table called music with other list of songs in there. If you do the load with a deep merge, the resulting it's basically going to be like a table with the content of the two tables summed together. There is no override. There is no data loss. Basically, you're going to have a complete merge of all the states.
I guess that pretty much changes how we see local cloud development, isn't it? Because it allows us to not just save our local state as a cloud pod, but it also allows us to specify how we exactly want to merge this state over here. So I believe the thumbnail lambda has been successfully loaded here. So maybe I can give it a shot and check whether I have the S3 buckets that you created. And I do see that I have the both of the buckets that are already present here. I can also go about and check the lambda function that originally created the thumbnail image. And I guess I do see the lambda function that has been created. I guess that pretty much passes the test that we can create some AWS infrastructure locally. We can save it as a cloud pod. We can push it to the platform and we can just get started with loading it on our own local machine. So that pretty much sounds great. Thanks a lot for showcasing us this demonstration.
Thank you very much. It was great to showcase it with you.
Yep. So I also want to discuss like what are the different use cases of local stack apart from just collaborative debugging, because like just creating a cloud pod, pushing it to the platform and just using us, like it is a good thing for developers, but what are the other things that I can try to do with cloud pods?
Like as we mentioned before, like the first use case is collaborative debugging. Let's say like allow people to actually debug some problems in a collaborative fashion. Let's say I'm facing some issue with my current stack and I ask you for help, and it's super easy for me to just take a snapshot of my stack and push it to you, and you can help me. Basically, you can basically recreate the same exact stack I'm facing problems with and help me debugging. This is like the paramount application we see for pods, but they can be used for like other different tasks. Like for instance, let's say you have some test that runs in your pipeline, and this test needs some states to be there that needs to be tested. And like interesting case is that we can create pods that contains test data, and this test data can be used to precede, like for instance, a CI environment. This is like another power feature that pods can enable. And also we envision some pods to be used for educational content. We can provide for people that want to learn how cloud works, and when they want to learn AWS, we can provide pods with some educational content. So they can just inject the pod into their local stack instance and start playing with AWS and with the resources they want to learn.
That sounds pretty great. I guess apart from all of this, cloud pods also give us an impetus towards reproducibility, because I have a slight of a machine learning background. So I definitely see that we can use cloud pods to not just create machine learning models, but also to save them, push them over to the local stack platform, or just use them as a remote, like use them in a remote provider. And this would allow people to have a completely reproducible environment where they can run the same experiments with the same results over and over again. And I guess this would give a huge shift towards people towards developing and testing their cloud and serverless apps locally. And I guess this is one of the paramount missions of LocalStack itself. Awesome. So if you're interested in cloud pods, you can always find some extra documentation about how to use cloud pods on our LocalStack docs website. So you can just navigate over here, and this would contain some extra documentation on how you want to use community cloud pods, which you can pretty much use without having to configure any license or without having to configure any API key. For people who are more interested in using the local stack platform as a way to store their cloud pods, they can definitely check out our team license and how they can use the extended CLI to basically go about these. And I guess that pretty much sums it up. So in the upcoming videos, we will be further talking about different use cases of cloud pods. We can talk about reproducible cloud development. We can also talk about some of the use cases that Joe mentioned, like preceding CI environments and much more about that. So I hope you have enjoyed the demonstration, and please make sure to subscribe to our channel. We are also active on various community channels like LinkedIn, Twitter, and Slack. And if you want to get started with local stack and or cloud pods, you can simply join our community Slack and you can kickstart a conversation with us. Have a good day, everyone.
Have a good day.